This is this looks like a slightly complicated function, but continuous and differentiable at every point, continuous at every point but not differentiable, differentiable and differentiable only at the origin. Now again, as we have seen, the exponential function is differentiable and continuous everywhere. Now here you have only 1 by x. So obviously at x equal to 0 it would create a problem, it would become infinite. That is why you can see that they have excluded 0 from the domain, and then they have defined specifically for x equal to 0 the value is 0. So let us check the continuity. If you see, this is e raised to minus 1 by x. If you write that as 1 over, okay, the answers, the correct answer for this now is continuous and differentiable, continuous but is not differentiable. Let us see what happens, okay. Continuity, as again we said, the continuity can be a problem only at 0. Nowhere else it would have. Otherwise, it's a normal function, exponential, polynomial, and product of those. So it should not have any other problem. So only at 0 it could be a problem. Let us see what happens when you take this. This becomes, if you take this LCM 1 over e raised to 1 by x, this would become e raised to 2 by x. This would also become e raised to 2 by x. And as x tends to 0, e raised to 2 by x would tend to infinity. And you can see that just like we have said here in the last class, in a polynomial function, if we have infinity by infinity situation, then if they are of equal degree, then the limit was a by b. Here, you don't have polynomial, but this is e raised to 2 by x and e raised to 2 by x. They are both identical functions. So their limit would be 1 as x tends to 0. This limit would be infinity by infinity, but the value would be 1 and the value of x would be 0. And therefore, the limit of this function would be 0. And this will happen whether x is negative or x is positive. It doesn't matter, because it is, you are talking about e raised to 1 by x. So even if x is negative, it does not matter. It will be 0. This would be 1 in both the cases, and multiplied by 0, it would be 0 always. So it will be continuous everywhere. So it could be A or B or C, of course. So let us see what happens to the derivative. Let me see if they have a calculation so that you can see very easily. Okay, they have shown you how to find the limit. They've shown the limit is 0 from one side and limit is 0 from the other side, and therefore the two limits are equal and the function is continuous. And then let us see what we are doing for differentiability. Now here what happens is, differentiable when you have h and minus h over here from one side, and h and h from the other side, because you will take positive value of h and negative value of h. Now this again, as h tends to 0, this whole thing will tend to 1. This just like what we did for finding the continuity. This would, the entire thing would tend to 1. So the derivative would be h divided by minus h would be minus 1 from the left hand side, and it would be plus 1 from the right hand side, and therefore the function is not differentiable at 0. The left hand derivative is minus 1, the right hand derivative is plus 1, and therefore it is not differentiable. It will be difficult to understand, but you can go through this part once again later on, and then it will become clear.